In this video, we're going to be approximating relative minimums and maximums. We're going to use a graphing utility to do that. So during a 24-hour period, the temperature Y in degrees Fahrenheit of a certain city can be approximated by the model Y equals 0.026 x to the third minus 1.03 x squared plus 10.2 x plus 34, where x is between 0 and 24, where x represents the time of day, with x equaling 0 corresponding to 6 a.m. So let's mark that. X equals 0 is 6 a.m. And we're going to approximate the maximum temperature during the 24-hour period. Now this is also important that it's asking us specifically for that maximum temperature. So here we're going to be approximating our maximum value, and we're going to do so with the help of our calculator. So we're going to go ahead and we're going to plug in our equation. And so we have 0.026 x to the third minus 1.03 x squared plus 10.2 x plus 34. Now because we're going between 0 and 24, we can adjust our window so that our x minimum is 0, or maybe even the -1, just so that we can go a little bit past that. And our maximum would be 24. So we'll put 25 there, and we'll go ahead and let's just count by ones, right? So let's graph that. Let's see what that looks like, and we might need to adjust our y's, but let's take a look. So we're going to go ahead and we're going to hit graph, and we see that our y scale is definitely not where it needs to be. So we're going to go back in, and let's make our y minimum a 0, and let's make our y maximum something like, gosh, it says the temperature for the time of day. So I've known temperatures to get up to at least 120. So let's put 150 for good measure, and then let's go ahead and let's count by something a little bit more reasonable. Maybe we're going to count by 20s. Now let's hit graph. We have a way better idea here. So as we look at this, we could probably even zoom in a little bit more. Let's go ahead and adjust that window. So we'll take our y maximum down just a bit, maybe to 100. There we go. And so we're looking for this relative maximum, which is going to be right about here, right? What time of day does that happen? So we're going to go ahead and we're going to use the maximum feature on our graphing utility. So in order to do that, we're going to hit second, calculate, and we're going to calculate that maximum value, which is option number 4. So it's asking us for our left bound, meaning this blinking cursor needs to be on the left-hand side of where we think that maximum value is. And right now, it's on the right-hand side. So we're going to arrow over until we get to the left-hand side. So we're pretty sure that our maximum is right here somewhere. And so our cursor is definitely to the left of that. So we're going to hit enter. Now it's asking us for the right bound. So it wants you to be on the right-hand side of that maximum value. And right now, we're on the left-hand side. So we'll go ahead and we'll arrow over till we're on the right-hand side. Yep, looks like we're on the right-hand side, so we'll hit enter. And now it's going to say guess. Because remember, when we're using our graphing calculator, that's really just an approximation. And so what we're really checking here, why it hasn't told us the answer, is it wants to make sure, is your maximum between the two lines you've just formed, those two dashed lines? And we can see that it is. So we can hit enter, and we see that we have a maximum of 63.9 degrees, and that happens at about 6.6. So when x equals 6.6. So let's write that down. So that happens when x is approximately 6.6. Let's just double check that and make sure. Yep, 6.6. And our y value there was approximately, let's go look at that, 63.9. So let's see here, 63.9, which is going to be approximately 64 degrees. Oops, not percent. That is definitely the wrong symbol. Let's try that again. Percent. So remember that x equals 0 was 6 a.m. So we need 6.6 hours past 6 a.m. So if 0 equals 6 a.m., then we're going to add 6.6 hours. Let's try that again. There we go. 6.6 hours. Now, we know that if we take 6 a.m. and we add 6 hours to that, that's going to give us 12 o'clock. So this right here, this 0.6, this is going to represent the minutes. So we need 0.6 of 1 hour. So we're going to multiply that, 0.6 of 60 minutes, because remember, we want it in minutes, and that's going to tell us 36. So 36 minutes. So 6 hours past 6 a.m. is going to be 12:36 p.m. So we can say that the maximum temperature of approximately 64 degrees occurred at 12:36 p.m. And we're finished.